Hello and welcome. In this video, we are diving into an important concept in blockchain, chaincode interoperability. We will explore how this concept empowers integration by enabling different chaincodes to work together. First of all, it's important to understand what interoperability means in a blockchain context. It's simply the ability of different chaincodes within the same network, but not exclusively in the same channel, to communicate and interact. And how these chaincodes communicate? It's like a client application does to communicate with a chaincode. It's through the transaction location, one chaincode requesting services or data of another by invoking a transaction and get its result. Taking a look in the chaincode stub interface, which is an essential sort of toolbox for chaincode development, we see the invoke chaincode function. This function allows a chaincode to invoke another one by providing its name, arguments, which includes the transaction names and other parameters, and the channel it belongs to. And it brings practical benefits that impact our blockchain networks. We are talking about enhancing functionality, allowing specialized chaincodes to work together to tackle complex tasks. And in that manner, we have modular design because we break down tasks into smaller and manageable parts. So each chaincode with its own responsibility. And it also simplifies the development and the maintenance of the system's functionalities. So the adaptability issue also comes as a benefit since you have different tasks decoupled. As a result, any change made has little or no impact on the other chaincode. There are some considerations that I believe it's important to point out. Invocations of transactions from one chaincode in one channel to another chaincode in a different channel do not impact the ledger stage. They function solely as data queries, meaning that the data in the other channel remains unchanged. Ensure endorsement policies alignment. When one chaincode invokes another with different endorsement policy, it's crucial to ensure that the policies align to prevent conflicts. For example, suppose a scenario where chaincode 1 invokes a transaction from chaincode 2 and chaincode 1 needs endorsement from organization A, but organization 2 requires endorsements from organization A and B. This situation will lead to conflicts in transaction validation. Finally, when transactions involve multiple chaincodes within the same channel or across channels, Hyperledger Fabric ensures that all endorsements and updates occur atomically. Either all of them succeed and are committed, or none of them are. This ensures data consistency and maintains the integrity of the blockchain. Let's dive into a practical scenario where there are two chaincodes, one to manage a product stock and another for handling payments. What's exciting is how they team up when we get a new order, each one with their own responsibility. When the first chaincode receives an order, it talks to the payment chaincode and they each do their job. Taking a look at the stock management chaincode, we can list what it does, highlighting the role of this chaincode, which involves checking product availability, calculating the total purchase amount, updating the quantity of the product in stock, and triggering payment processing. This is when the second chaincode comes into play. This execution flow illustrates when every step is taken, so let's walk through it. First, the user orders a product, which means that the client application invokes the order product transactions with the client and merchant information, besides the product and amount that was ordered. So next, the chaincode checks if there are enough products available in stock for that order. If there are not, it terminates the transaction with an error. But if there are enough products available, updates the product stock by just modifying the asset that represents the product stock. After that, it calculates the total purchasing amount based on the unit price registered in the ledger. With that information and the customer and merchant ID, it invokes the chaincode payment to process it. Then, it checks the transaction invocation outcome. If payment succeeds, it registers the sale by saving an asset with relevant information about it. If don't, it ends transaction with error. Now it's time to take a look at the payment chaincode, which is in charge of checking buyer account balance, updating buyer and merchant balance, and registering payment asset. The execution flow is a little bit simpler. When the stock management chaincode triggers the payment by invoking the process payment transaction with the total amount related to the purchase, it first checks the user balance to ensure that it's possible to transfer the required funds to the merchant balance. If there is no sufficient balance, the transaction is ended with error. But if so, the funds are transferred by just updating the total balance property in both merchant and user account assets. It's important to know that this approach is not recommended in a real-world scenario, especially within financial context where precise balance tracking is crucial. I didn't focus about these details because this was a simplified example just to illustrate how powerful can be interchain code communication. Moving forward, the next step involves registering this financial transaction with some important information like date, total, etc. in an asset. Finally, the transaction concludes without errors. So let's see this example running. First, I'm going to quickly introduce the chaincodes code. We used the CC-Tools library for the development, which made things a lot easier. Starting with the stock management chaincode, these are the assets involved. A product stock asset containing the product ID, available quantity, and unit price. And an asset to record a successful sale containing the product reference, date, quantity purchased, and the total sale value. Additionally, it includes the payment transaction ID, which is obtained after invoking the payment chaincode. The only implemented transaction in this chaincode is order product, which performs the procedure explained earlier. And as you can see, the client application needs to provide the merchant and buyer account ID, the product asset reference related to the purchase, and the required quantity. So with this information, the entire process is executed, and it's in the process payment function that the payment chaincode is invoked. Now let's move on to the payment chaincode. Here we have an asset representing the user's account, simplified with just an ID and balance. Additionally, we have an asset representing the record of an executed transaction. It's this ID that is utilized in the stock management chaincode within the sale asset. So we also have reference to the merchant's and buyer's account along with the total transferred amount. Next, I'm going to show the transaction called by the other chaincode, which is named process payment. As you have already seen in the other chaincode, you need to provide reference to the merchant and buyer's accounts assets along with the total amount. The flow demonstrated earlier for payment is executed and the response is returned. Before demonstrating in action, I want to mention that we have also incorporated the create asset and read asset transactions implemented by CC-Tools library into both chaincodes. With the network up and running, I'll start by creating the accounts for a merchant and a user. Next, we need to have the product to register in the system. So I'm going to create a product with the ID product1, priced at 50 per unit in an initial stock of 5 items. Now I'm going to make user1 buy this product in a quantity of 2. And as there is sufficient balance in stock available, the purchase is succeeded. Now I will see user's account after this purchase. We can see that the amount has been debited. I will also take a look at the merchant's account, and there we can see that the amount has been transferred. We will also check the product stock, which now shows 3 items. Finally, I will attempt to make another purchase of just 1 item by the same buyer. And as expected, we received an insufficient balancing error since the first purchase used up their balance. That's it. I hope you enjoy it and see you next time.